As Kelly said, my name is David Wharton. I am a staff threat detection engineer at Uber. And today we're going to talk about taking control of your Suricata rules with Aristotle v2, mastering metadata to form the rule set you want and need. Originally, I had a much longer title, but Kelly made me change it. She said it was too long. Actually, that's not actually true. She would never say that. She's too professional, but I know she thought it. My wife told me that I was just using big words in order to make myself look smart. So I had to mansplain to her, which is always the right thing to do when your wife criticizes you. No, I told her that she might be right, but I need all the help that I can get. So I changed the title anyway, and we're still married close to 20 years, so maybe there's a life pro tip in there somewhere. But today we're going to be talking about controlling your rule sets. So I don't know why, I apologize, I don't know why this mirror screen's thing's here. Actually, just one second. Close this. All right, apologies. So we're going to talk about some problems with rule sets. We're going to talk about solutions, challenges, and then a piece of software called Aristotle v2 that can help you take control of your rule sets. Now, most of you, I'm guessing, have some type of third-party rule set that you're using in your environment. And typically, when you get a third-party rule set, you're like a kid on Christmas. You open it up, you put it on your sensors, you turn it all on, and you're all excited. And then typically one of two things happen, or actually both things probably happen. One, you get a bunch of alerts, and two, your sensor performance starts to suffer. So you quickly realize that, hey, I can't run all these rules in this rule set. So what's the solution? Well, then you have to do what's called rule set tuning. Whoops. And rule set tuning is easier said than done, right? It sounds easy, right? You just take your rule set, sprinkle a little tuning on it, and then it's going to start working exactly like you want. But it's not that easy. So when people talk about rule set tuning, typically what they mean is disabling and enabling rules that you want for your particular environment, and optionally modifying some of those rules for your needs. Yeah, and we'll come back to that in a second. So the other thing I hear everywhere I go and every company I've worked with that's dealt with a third-party rule set of any size is that it produces too much noise. It's got false positive, it's got alerts on things that may be true positive, but the company doesn't care about, policy violations, all kinds of things. And so that's one of the big complaints. And so that's where the tuning comes into play. And so how do you tune your rule set? Well, there's the one approach is a manual approach where you individuate the rules by the signature ID, you inspect them individually, you make decisions on whether you want to turn them on, turn them off, maybe you modify the rules. But this is a very manual process. It's very onerous and it doesn't scale. It's kind of like when you first started shaving. It was new and exciting, and you thought you were becoming a man, and pretty soon you figured out that it was a big chore that took a lot of time. And I have talked to companies, maybe there's some in this room that do this, where you do inspect every rule that comes in. The rule set provider provides an update. You go through it individually with your team, and you decide whether you want to keep it or modify it. But again, that doesn't scale. And what happens when your upstream provider updates the rule and makes changes, and you've made changes? How do you merge those changes? So another approach is the more traditional approach is by using the class type or the file name. So in each rule, typically there is a class type keyword that tries to classify the rule into a set of finite categories. Typically, there's about 24 class type categories that rule set providers provide. This is really a holdover from Snort from 20, 25 years ago. But these class types are things like attempted admin or bad unknown or policy violation or malware. And similarly, you can split your rules into different files and only load certain files. And your rule set provider probably does that, where they have SQL.rules or ActiveX.rules or Web.rules. But it's a very broad approach, because what if you want some of the rules in the exploit.rules files, but not all of them? And there's not a one-to-many mapping, where one rule can only live in one file, or one rule can only have one class type set. So what do you do if you have a rule that detects recent web exploit kit activity? Should that go in web client.rules or exploit.rules or recent event.rules? You can only go in one of all the rules if you're loading all those files. So how do you pick? So it's a very blunt, broad approach. And then there's the SuriCon update approach, which can do everything that we've already talked about, along with filtering by group ID. It provides the ability to do regular expression-based filtering, which is nice. It can do filtering based on metadata, but it's still somewhat of a static approach, and it may not be flexible enough for your environment. And I'll also say that nothing in this talk is intended to be critical of or speak pejoratively against SuriCata Update. I know Jason Ish, who wrote and maintained SuriCata Update, is sitting right here a few meters from me. So if you use SuriCata Update in your environment and it works for you, then my encouragement is to keep using it. If it works, that's great. It's the right tool for you. But in my case, it was good, but it wasn't flexible enough. And in fact, I actually use SuriCata Update in a lot of cases to download and compile the rules and maybe do some broad filtering. And then when I need to do some more complex stuff, then I'll use Aristotle to do that. So SuriCata Update was on the right track when it provided the ability to filter based on metadata. And so the secret to rule set management lies with metadata. Now you'll hear the M word used a lot this week, and it may not always mean the same thing. So when I talk about metadata, I'm talking about a SuriCata keyword that allows you to specify key value pairs, where the key value pairs are comma separated, and within each key value pair, the key is the first word and the value is the rest. The metadata itself does not contribute to the detection, meaning it's non-functional when it comes to detection, but it provides information about the rule, it lives with the rule, and it can be arbitrary. So you can put whatever you want in there, as long as it supports the supported character set, typically ASCII. And you can do a one-to-many mapping, so you can have the same key name and then multiple values for that, a list of values. And the metadata itself comes from the rule author or wherever you get your rule sets from, they set that. So a quick example a simple example would look like this. You have the metadata keyword in SuriCata, you have the key priority and the value medium, key protocols, value SMTP, key protocols, value TCP. So you can see that one-to-many mapping, and this is how you would define it in your rule. And if you were to look at a bigger rule or a full rule, it would look something like this, and you can have as much metadata as you want within reason, I'll say. And the other nice thing is that metadata lives with the rule itself, so it can be used on the front end for filtering, but it is also included in the Eve log. So it's included with the alert in the output, which can be extremely helpful for an analyst that's looking at an alert and then wants to understand it, or for programmatic consumption by your SOAR tools to run automated playbooks and actions against particular alerts. And let me talk just for a second about the better schema. So 5 years ago in Amsterdam at SuriCon, I presented on the better enhanced teleological and taxonomic embedded rules schema and standard, where I attempted to define a simple schema for some common metadata keys, along with some value formatting rules, and in some cases finite values for certain keys. And then there were some simple standards around that, things like metadata should be case insensitive. So if you're interested in that standard, that talk was recorded. It's on YouTube. The documentation is on Read the Docs. And so if I refer to the standard, this is the standard I'm referring to. It never, to be honest, it never really caught on with many vendors. I was at SecureWorks at the time. We had a SuriCata rule set that was tens of thousands of rules that I worked on and led the development of that. And so we did update all our rules with metadata according to the better standard, but nobody else did. Still a good standard, but despite my pleadings with vendors, it never really got a lot of traction. So back to metadata. So ideally, a rule should contain rich metadata. It should contain good metadata that describes what the rule is, what it's looking for, what it's about, what it applies to, and it should provide enough information so that the end user or the end user's program or script can consume the information, understand what it's about, and make decisions about should I include this rule in my rule set or not. So that's in the perfect world, we have perfect metadata. But what if the rule set doesn't have good metadata? We'll get to that. And what tool could be used to take advantage of rich metadata if it existed? That tool started off as Aristotle v1, which I released in Amsterdam in 2019, and allowed you to do rule set filtering based on metadata key value pairs. It provided the ability to specify Boolean logic, so and or not, and uses the metadata key value pairs as values in a concrete Boolean algebra. We'll look at kind of what that looks like, but the idea is you can create what I call a filter string that defines what rules you want to match on, and which can then control which rules you want to keep. Aristotle v1 can also provide metadata statistics. So if you have a rule set and you say, what metadata do I have now? It'll show you that. And Aristotle v1 only just turned rules on and off. It didn't modify anything. So just a quick look at the statistics. If I want to know what's in my rule set, Aristotle can tell me the keys and the counts. If I want details on specific keys and values, it can give that as well. And then there's what I mentioned, the Boolean filter string. So here's an example where I have priority high and malware all. So I'm looking for, in the metadata, I'm looking for the metadata key priority with value high, and the metadata key of malware with any value. So any rule that has priority high set in the metadata and has the malware metadata key will match on this. Similarly, that bottom rule looks for priority high, and it looks for a rule that was created at within a certain range. So for some metadata keys, you can do greater than, less than, ranges, which is kind of nice. So date fields, CVEs. So here I'm looking for a high priority rule that was created in 2024 or has a CVE reference of 2023 or greater. So Aristotle v1 provides powerful Boolean filtering, but it's only as useful as the metadata that you have. So we need to talk about your metadata. Rule set providers do not always provide good metadata. When I say good, I'm not making a moral argument. I'm saying it's just not rich, informative metadata. One of the big issues is it's not comprehensive. There's only some keys on some rules. If you look at, for example, the emergent threats rule set, they have a metadata key on some of their rules called confidence, which is great. That can be very useful, but it only exists on about 2% of the rules. So it's not very useful as a to use for filtering the entire rule set. You also have things like inconsistent metadata, where you have a CVE key that's supposed to represent a CVE value, but the value format is inconsistent. So you have a bunch of different formats, and if it's not predictable, then it makes it very difficult to create rules that match against it. And then you have something that I call poor life choices. I have 3 young sons. We talk about making good life choices and not making bad life choices. And they know that not using ISO 8601 in a normalized date field is a poor life choice. And the last thing I'll say is that your rule set provider is unlikely to change. It's unlikely to add rich metadata overnight. And in their defense, it takes time. It takes time to do it right. The way you do it is like eating an elephant, one bite at a time. So one rule at a time. As you create it, you maintain metadata with it, and then over the years, you have a very large and rich rule set with good metadata. So what's the solution here? What can we do? This is where Aristotle v2 comes in, version 2. All right, so Aristotle v2 adds a few things over Aristotle v1. One, it updates the filter capabilities, so it updates what you can, how you can filter. Specifically, it adds regular expression support. And then it also does some things. First, it can do metadata normalization, which we get to. It can do metadata enhancement, which means adding metadata to your rules automatically. And then finally, there's something I call post-filter modification, or PF mod, where you can set up rules to then further modify your rule set as needed before it reaches its final form. And we'll talk about each of these capabilities. So the first thing I added was the ability to do regular expression matching in your Boolean filter string, which is extremely helpful, although there is a performance hit, but performance really isn't a top priority for Aristotle. So you can apply regular expression match against just the message field, or you can do it across the entire rule itself. And then there's what I call normalizations, where Aristotle attempts to, we'll say, fix existing metadata. So things like CVE keys, it attempts to put into the standard format. Similarly, the MITRE attack key attempts to make standard compliant as well. And then finally, the date key names and values, it attempts to convert the values into standards compliant, specifically ISO 8601, which better also is congruent with. So you have normalizations, and then you have enhancements, where we're trying to add to our metadata, because it's all about the metadata. So we want everything in this normalized metadata field where we can then apply our filtering logic against it. So anything we can take from the rule and then represent in the metadata, so it's all there in that same place, is valuable to us. Because otherwise you're left with doing some complex grep or some pattern matching gymnastics that becomes very difficult and error prone. So some of the enhancements that Aristotle v2 offers is things like flow. It'll take the flow keyword and the values and stick those into the metadata. And it'll also normalize the to server and to client, from server and from client, to always be either to server or to client where applicable, so that you always know that if you have a flow to server, it's going to be represented as to server and not as from client. The protocols key, it adds, so if you have a rule that says alert HTTP, you're going to have a protocols metadata key of protocols with value HTTP, and you're also going to have protocols TCP. CVE and MITRE attack, it attempts to kind of extract from the rule itself if there's some mention in the rule name or in references and things like that. And then there's the hostile key, which is really the inverse of the target SuriCata keyword, which I argue should have never been its own keyword, should have just been a metadata key to begin with. but and I know that Eric implemented that, so I'm not trying to be critical of that, but I don't want to have to fight you in the parking lot later. So there's also the class type and the file name keys. So these are still, class type and file name are still incredibly useful, but by themselves they're not enough. And so we'll take the class type keyword, stick that in the metadata. Now we can use that for filtering. If you loaded the key from a file, stick the file name in the metadata. We can use that as well. Aristotle supports processing rules from a directory, so you can give it a directory full of rules files, and it'll load them all up, and it'll populate the file name, metadata key as appropriate. And then the last one is detection direction, which we'll discuss. And this was really, if I'm honest, the thing that got me out of my seat and working on a new version of Aristotle was because of this. And detection direction attempts to normalize the directionality of traffic that the rule detects on. Now you might say, oh, well, we already have the source IP field and the destination IP field. We already have flow. Why do we need this detection direction? Why is it any different? Well, the source IP and destination IP fields in the rule match on the layer 3 header, match on the IP header, and the flow to server, to client, all that matches on the layer 4 TCP flow state. But here we're trying to record the directionality that the rule is trying to detect on. So if you have a rule that is looking for traffic from home net to external net, I would call that an outbound connection. Or if you're looking at traffic from external net to home net, that would be an inbound connection. And if you look at all your rules and you look at the values of the source and destination fields, they can be reduced down in almost every case. I'll say almost, I don't want to say 100%, but all the ones I looked at, you can reduce down these rules to a finite set of reduced conditions. So even though you might have a variable that's not external net, you can reduce that down based on the values of that variable. Maybe it references another variable. Aristotle v2 will recursively try to reduce down all the source and destinations to this set of 7 reduced conditions. So ultimately, if your rule is going from external net to home net, we call that inbound. If it's going from any to home net, that would be also inbound but not exclusive. Home net to external net is outbound. Home net to any is outbound, non-exclusive. Home net to home net is internal. And then any is just labeled as any. And then your bidirectional rules, which there are a couple of them out there, are just labeled as both. So you have this detection direction value that is set as well in the metadata. And I'll show you an example later on where this really comes in handy. So just a quick example of a before and after the normalizations and enhancements. So this is ET rule that I pulled this week. And in the green, or well, say in the orange, you can see the normalizations that have happened. So the dates are fixed and things like that. And then in the green are the metadata fields that have been added automatically by Aristotle by looking at the rule. So Aristotle v2, back to the diagram, you give it a rule set, it can do normalizations, it can do the enhancements, and then you can apply the filter string to determine which rules you want to keep, and that step is what Aristotle v1 did. And then you're left with this rule set that's maybe what you want, but maybe you need to do some additional filtering or some modifications of the rule on the fly. And that's where post-filter modification comes in. And post-filter modification has this idea of rules, and I don't want to be confusing because SuriCata has rules as well, so I'll try to say post-filter modification rules to distinguish, but pfmod rules allow you to further filter and modify the rule set after the initial filter string and after the normalizations and the enhancements are applied. And so what it lets you do is select groups of rules and then perform specific actions on them. And how do you select which rules you want to operate on. Well, you use a filter string, again, against the metadata. And then there's a number of actions that you can do. So you can disable a rule if you hadn't disabled it previously. You can add, delete, copy, modify metadata as you want on those particular rules. You can set or modify certain SuriCata keywords. And then if you really need to bring out the big guns, you can do a regular expression-based find and replace on the entire rule. These pfmod rules are YAML-based, and you can have a pfmod YAML file that references other files that get included, so you can have a big set of pfmod configurations that apply to your rule set. The files are processed in a depth-first search order, and within each file, it's processed from top to bottom. The pfmod rules are. So you can have a very broad pfmod rule that modifies many rules, and then you can have a subsequent rule that then operates again on a subset of those rules. You can really do what you want. Just a quick view of kind of what a pfmod rule looks like. This is actually two rules. You have a name, which is optional, if you can read this. The name comes in handy if there's an error, because it'll show up in the error log. It's not required though. And then you have a filter string which says, okay, these are the rules that I want to operate on. So that defines the rules that you've selected or that you've grouped, and then you have a list of actions that you can perform on those rules. So what actions can you do? We can set and modify certain SuriCata keywords, things like message if you want to change that, or threshold, or priority. One thing about the integer-based keywords like priority is you can do relative modifications. So you can say +1 to increase the existing value by 1, or -1 to decrease. You can also modify metadata. You can copy metadata if you want to copy the value from one metadata key to a new key. You can do that. You can add metadata. Remember, metadata is whatever you want. Really, you can put whatever you want in there, whatever makes sense for you in your environment. So you can add metadata. You can add metadata exclusive, which means replace this metadata key, all instances of this key, with this key value pair that I'm providing. And you can delete metadata based on a specific key value pair, or you can delete metadata based on a key alone, where it'll delete all instances of that key. And then the other thing you can do is set and update arbitrary integer metadata. So if the key name is not one of the, I'll say, protected key names, you can just set an arbitrary integer-based metadata. So at Uber, we have this concept of a risk score that we apply to all our security alerts, and that gets considered in our back-end aggregation and correlation algorithms and ML models and things like that, in order to determine should we create a case, should we start an investigation, should we kick off automated playbook, whatever. So there's this idea of a risk score that I want on all my rules. So I can just say set risk score and give it a particular value. Or I can do relative modifications. So I can say increase by 10 or decrease by 50. So this second one where I say risk score -10, 50 means for all the rules that this applies to, all the ones that have matched my filter string, if there's a risk score metadata value set, decrease it by 10 and store that. If not, set it and use the default value of 50. So there's a lot of things you can do, especially with the integer-based stuff, dynamically with the pfmod rules. So we're going to look at 3 examples, and then I'll conclude. So this is at the top, emerging threats rule. It gets normalized and enhanced, and that's what you see at the bottom, which is this rule. The orange is the normalizations, the green is the enhancements. And let's say I want to build a pfmod rule for this. So I would define my YAML, I can give it a name, I would give it a filter string, so this defines which rules I want to operate on. Here I have just a single rule as an example, but really it would apply to all the rules in the rule set that match the filter string. So here I'm saying file name, emerging scan.rules, And so all the rules that have that metadata key value pair would match, and then the actions I take against it, let's say I want to add metadata exclusive risk score 10, I want to, oh, there we go, it adds it, right? That's my entire rule. So now I've got a new risk score value, or excuse me, I've got a new metadata key value pair risk score and 10 on all the rules that matched. Let's say I want to apply another rule where I do a very similar thing, filter string, file name, merging, scan.rules, and signature severity is critical. So for all those rules that have the signature severity metadata key and the value is critical, we want to perform some actions. And in that case, I want to increase the risk score by 40 if it exists. If not, set a default value of 10. Now, if you're following along, you'll know that in the previous rule is a superset of this second rule, and so all those rules will already have risk score set to 10, and so there won't be any that don't have it, so the default value will never get set in this case. But for the rules that do match, that have that signature severity critical, it will get a boost of 40, and so then in this example, risk score will now be 50. Hopefully this is making sense and I haven't lost you. We'll look at another example. Same setup, rule from the emerging threats rule set. It gets normalized and enhanced, and we want to apply a PF mod rule against it. So this is what we would call an IP rule. And so I'm going to create a filter string to match rules of this type. So I've got a rule regex, which if it doesn't make sense, really it's just looking for rules that start with alert IP or another action in IP. So we're looking for just the IP rules. And then we also want to look at just those that are detection direction inbound. So this would be traffic coming from external net to home net. And we want to exclude the rules that have signature severity major and signature severity critical. Does that make sense? Because these IP rules, they're populated typically from known block lists or bad lists, and they can be useful, but they can also generate a lot of noise. And because I know we get scanned all the time, and even my home network gets scanned all the time, and these rules are going off, and it's just noise. They get blocked. There's no action to take against them. So if you want to turn them off, you can match on them like this, and you can say just disable. Or if you want to keep them on, you want to lower the priority or set a low risk score, you can do that too. So here we've got all remember the group here is the IP-based rules where the detection direction's inbound, so it's external net to home net, and we're ignoring the major and critical rules, so we're catching the things like that may not have signature severity set or signature severity set to something like minor. So we set in this case, we set our actions are, we're going to set a low risk score, we're going to set a low priority metadata keyword, we're going to set priority 5. This updates the priority keyword in the rule, and there you go. And the last example is this ET-scan WordPress scanner. It gets normalized and enhanced, but let's say we need to make some changes to it, because if you're running a rule or rules like this, you probably have the problem where your internal vulnerability scanners are triggering this rule and causing issues. So you have rules like this. I see it a lot with log4j, and if you have an internal IP that's performing exploit-related traffic, that is something you want to look into, except when it's sanctioned and it's your vulnerability scanners. So how can I identify these rules that may trigger on such activity and update them so that I'm not being alerted on them by my vuln scanners? And on this one too, let's assume that, so this is a threshold-based rule. Let's assume that these threshold numbers are a little low and we want a higher threshold before we see an alert. We can update the threshold keyword as well. So let's create a PF mod rule, call it scanner cleanup, filter string. We say, okay, all the rules that have class type network scan or have the word scan, all caps, or the word scanner in the message we want to match against. And we want the rules that are have flow to server, so we know the traffic's going to the server, and the detection direction is inbound, not exclusive. Now we could, if we want to say inbound, detection direction inbound instead, or both inbound and inbound, not exclusive. In this example, it's just inbound, not exclusive, but I know that this is a scan-based rule. It's going inbound to my network, it's going to the server, so it's traffic coming to my own web server. And then the actions I want to take against it. We'll set risk score 20, we'll set priority low, and then let's update the threshold keyword, because let's say count 4 seconds 8 is a little low for us. We want to change that to count 10 seconds 120. We can do that. And then we'll do a regular expression find and replace to update that source IP variable. So don't worry about trying to grok the whole regular expression. Just understand it's looking at, and we'll see the output. It's basically taking the source IP variable and excluding the vuln scanners from it. The assumption here is you have a vuln scanners variable defined in your SuriCata.yaml that has a list of your known vuln scanner IP addresses. So when we run this, you can see that the source IP gets changed to be any except for your vuln scanners, and then the threshold keyword gets updated, and the defined metadata gets added, as well as the priority gets set. All right. So, in summary, it's all about the metadata. Aristotle v2 can help with filtering, normalization, enhancing, and modifying your rules. And hopefully you've seen that with Aristotle v2, you can take a third-party rule set, you can clean it up, you can add to it, and then you can define a number of pfmod rules to manipulate that rule set for your particular environment or environments and deploy it out. And this all happens dynamically. And so every time we download a new rule set, we pull it from our source, we run it through Aristotle, it goes through all the logic, all the rules get modified as desired, and then the rule set gets pushed out. So there's no longer any worry about, oh, well, what if the provider modified their rule and we modified our rule? How do we merge them? What if the provider creates some new rules that now we have to then go back in and tweak for? By operating on the metadata in the rule itself and creating the generic rules that try to capture what the rule does and apply your specific actions to those rules, you're able to programmatically deal with new rules that may come in. And I don't have a nice graph to show you, but I will say that I spent some time, I developed a number of pfmod rules and the filter string for our rules at Uber, and set it to run, and it's been over a year, and I haven't touched it. It's worked great. It's worked great. The last thing I'll say, there's a Uber engineering blog about this that talks a little more high level about this, but with nicer words and paragraphs and things like that, and some pictures. And then the code for Aristotle is on GitHub if you're interested. All right. Thank you very much.
Thanks, Steve. Great talk. So we are using Aristotle for our rule management, applying metadata filters. So we were using Aristotle version 1. But what we're doing is we're fetching the rules from our upstream using SuriCata update, saving them locally, and using Aristotle to apply filters on the rules, and then again modifying the rules and saving them locally. So this process a bit time consuming. It takes around a minute or two to go with the whole process. Is there a way I can use just Aristotle to maybe streamline this process?
It's a good question. So Aristotle does not provide the ability to download rules. That comes from really SuriCata update's your best tool for that. Now, years ago I did submit a patch. I'm looking at you, Jason. Submit a patch to include Aristotle in SuriCata update because it can be included as a library. And I remember flying to Amsterdam and writing it on the plane and submitting it when I landed. It did not get accepted. I'm not bitter. It, for reasons we can get into. But yeah, to be honest, I do what you do. I'll use SuriCon update to download the rule set, and I'll use Aristotle to do the filtering. It does take time, and I'll be honest with you, especially when you start doing regular expression, find and replace, and matching, performance suffers. And if you have some complicated PF mod rules, that suffers as well because to be honest, I did not write it with performance in mind, and so it's very inefficient where it reprocesses the rules many times. If you have 100,000 rules, it takes some time to update. I have cases, and it all depends on your hardware, of course, right? So hopefully you're running Python 3, which is much faster than Python 2, but it'll still take a good half hour sometimes for me to really curate my rule set, which is fine. I've got time. I'm not sitting there waiting. It's all automatic. It's all automated. So does that answer your question?
Yeah, all right. If you can share the patch with me, it will be really helpful, the one you submitted.
Oh, I think I mentioned it in that talk in Amsterdam.
Okay, thank you.
Yeah.
I want to try it. I'm interested, so I'm going to relook at doing some post-processing pipeline
Yeah.
from SuriCata update because.
Yeah, ultimately, so Aristotle uses a third-party library called boolean.py to do the Boolean filtering. And then on top of that, I do all kinds of list comprehension and, because it's so awesome, double list comprehension. So that's kind of what it does. But Jason didn't want to include it because it required a third-party library, which is totally fine. It's his prerogative. And I think it works to pipeline them, to have SuriCata update and then have Aristotle run. I mean, they're both Python. They're both, I don't know if you would get a big performance boost over integrating them. You would have, I guess, a single tool, but it's not really necessary.
Yeah, probably not much benefit to integrating them. There's just a script that
Right.
batches it up.
Yeah,
right?
just pipeline them together.
Hey, yeah, 2 points. Firstly, about the performance. Don't feel bad about it. I'm doing something very similar internally, and the only way to make it faster was to just partition and make workers. The part about normalizing the source and destination, right? So who is getting attacked, who is the attacker. So question maybe, or maybe even a proposal. There's a, let's say, not even a very niche case in the rule set where the destination IP doesn't actually matter. So, for example, DNS rules. It's actually a relay case where the query is going through your internal resources, so you can't just say that the destination IP or domain controller is attacking you, right? Maybe it would be useful to add this kind of metadata normalization as well, that the case is something like outbound relay, like DNS and SMTP both do it, where the bad stuff actually is relayed through something good, so the IP is actually, the destination IP is usually not even relevant for the analyst.
Mm-hmm. Or the destination IP would look like an internal HomeNet IP, but functionally it's really
it doesn't matter. If it's a DNS
net.
request, you can go to a Google DNS or your internal domain controller or whatever DNS resolver you're using. So it doesn't actually matter from a threat analysis point of view. What matters is the actual query.
Mm-hmm. Yeah, you can certainly, I guess, update your own variables as you see fit, and you can then, I wonder if you could define a Boolean filter string to identify rules where that applies to, and then modify them as necessary. Because what Aristotle does is it just looks at the ontology of the rule itself. So it only has what the rule gives it, and so it can't always divine situations where, this endpoint doesn't really matter. but you may be able to represent that in certain variables
Yeah,
and then operate on that.
I can tell you what the filter is. Basically, DNS query with just a content match, and that's actually like a huge batch of rules in ET, for example.
Yeah. Well, remember the metadata doesn't actually modify, doesn't actually affect detection. So even though it may be classified as an internal traffic, if it's internal DNS from a client to an internal DNS server, that'd be direct detection direction internal. It still just updates the metadata. It doesn't modify the detection at all. You could set like you could identify what you just described, and then you could say add metadata, and then you could give it your own metadata tag that you want on that. That could then be processed on the back end or handled by the analyst, however.
Yeah, like I just wanted to highlight it. It's like I treat it as one of the directionality cases, right? So you had the inbound, outbound, internal, right? But there's also like I like to keep the relay a separate class, so to say.
Yeah. Thank you.
Any other questions? Mr. LeBlanc, sporting his very sexy and awesome new jacket. Love it.
Now. Even did pay it now.
It is paid for now. Thank you.
Yeah, it's a simple question. Really cool job, by the way. Is Aristotle available as a module that you can inject in some of our Python code?
Yes. It's available in PyPy. You can load it as a module. Yeah.
Perfect.
Great.